Hi everyone, Engineer Keji Okan here. Good morning, good afternoon, good evening. Depends on what time you are watching this discussion. Right now, we are going to discuss about data visualization. It's Module 1A or Part 1 of Module 1 for Engineering Data Analysis. I hope you are seeing my screen right now. So, okay. The learning objectives for this discussion is that we wish for you to be able to be aware on the importance of data visualization, for you to describe different data visualization methods, as well as to present data sets in graphical form using Microsoft Excel. Before anything else, let's discuss first or recall what data is or what data are. Data are individual facts, statistics, or items of information, often numeric. So the keyword here is items of information. This means that we could not assume that data are already information, but somehow are like fragments or pieces of information that when treated or analyzed or grouped can become an information. So these are individual facts or statistics. So somehow it's a fragment or a piece of information. In a more technical sense, data are set of values of qualitative or quantitative variables about one or more persons or objects or any entities. While datum is the data and datum are the same. Data is the plural form of datum or datum. Datum is the singular form. Actually, we're all surrounded by data. These data are categorized into two. If you can see the um, illustration below, we have the quantitative or the numerical data, and we also have the qualitative or the categorical data. The quantitative data, these are data that are numerical in nature, and it has two subcategories, the discrete and the continuous data. The discrete data, these are data that are counted, such as the number of the members in a family, the number of cars or vehicles that pass through a bridge, and so on. So anything that is counted are called or is called discrete data. And the second subtype of quantitative data is the continuous data. Continuous data are quantitative data or numerical data that are measured, such as the height, the weight, the compressive strength, voltage, and so on. So if you are using a measuring tool or if you measure this type of data, we call it continuous numerical data. And then continuous data also has subtypes, the interval and the ratio data. The difference between the two comes from their ability to dip below zero. Interval scales or the interval data holds no true zero and can represent values below zero, such as time, right? So how about other examples? We also have temperature. Temperature, we can actually measure negative degree Celsius or Fahrenheit. So we call them interval data. The second is the ratio data or the ratio variables. These are items or data that never fall below zero. Example for this one are height and weight because it measures from zero and above. We don't have negative measurement for height and weight. Okay, and the second type of data is the qualitative data or the categorical data. These are the opposite of quantitative data, or not totally opposite, but these are non-numerical in nature and are often described in words. Qualitative data have two subtypes, the nominal data and the ordinal data. Nominal data are often used for naming variables such as the brand of cell phone, hair color, day of the week, and so on, and a lot of other things. If we are dealing with naming of a certain data or we put them in categories, we call them nominal data. However, if nominal data are put in a scale or grouped together or grouped together in a scale, we call them ordinal data. So these are examples of ordinal data are happy, neutral, or unhappy. So Happy, neutral, and unhappy are actually nominal scale if they are, I mean, nominal data if they are taken alone. However, if you put them in a scale from 0 to 1 or negative to positive range, these nominal data become ordinals because they have a certain scale or they have an order of value. So example there, 1 is equals to happy, 2 is equals to neutral, 3 is equals to unhappy. Sometimes there are scales such as there are satisfaction scales, 0 for unsatisfied, 1 for neutral, and then 3 for satisfied. So and so on. And then, yeah, now that we know what data are, let's talk about data visualization because this is what our topic is all about. Data visualization is actually just a simple graphical presentation of information or data. By using visual elements like charts, graphs, maps, or even tables, data visualization tools provide an accessible way to see information and understand information in terms of trends or in terms of outliers or to see patterns in the group of data. Actually, our eyes or our brains are drawn to colors and pattern. We can quickly identify red from blue, square from circle, and so on and so forth. Our culture is actually visual. The human mind is wired or programmed that way. We are visual in nature, including everything from art and advertisements to TV and movies. Data visualization is another form of visual arts or visual art that grabs our interest and keeps our eyes on the message. When we see a chart, we quickly see trends and outliers. We see patterns quickly than if we are going to, I mean, quicker if compared to if we're just going to read the raw data alone. So it's a different mind function or mind processing if we see charts or if there are visual presentation of those data. When we see chart, I know it's actually if we can see something, we internalize it quickly. It's much quicker than reading the raw data alone. So it's somehow like a storytelling. So the data is telling a story to us. So that's the main purpose actually of data visualization. So if you've ever stared at a massive spreadsheet of data and couldn't see a trend, you know how much more effective a visualization can be. Data visualization helps to tell stories, again, by curating data into a form easier to understand, highlighting the trends and outliers. A good visualization tells a story, removing the noise or the unnecessary information from data and highlighting useful information. So the illustration below is an example of a data visualization. So there are actually different types of methods on how you visualize data. So these are the common types of data visualization chart. We have the line chart, we have the area chart, the bar chart, the histogram, scatter plot, bubble chart, the pie chart, gauge, map, and heat map. So in our lesson for today, we are going to apply or we are going to create these charts using Microsoft Excel. Hold on. I'll open my worksheet first. There. So I want you to remember this simple guideline in data visualization. So this is somehow like a cross-functional table on how or on what appropriate chart you're going to use. It depends on what you are going to tell with those data. So if you're going to compare data, bar graph is appropriate for it. So if you're going to break data into parts and then you also want to compare data, you can use stacked bar graph. And then if you're going to break data into parts and then you just simply want to break data into parts, you can use pie chart, bar graph, or stacked bar graph. And then if you wish to see data over time and then you wish to compare them at the same time, you can use bar graph or line graph. And then if you want to see data over time and then at the same time you want to break data into parts, you can use stacked area graph or stacked bar graph. And lastly, if you want to see data over time only, you can use line graph, area graph, or bar graph. So let's work on these 10 worksheets below from 1 to 10, and let's go ahead and create graphs on the data given. First is this one, the population of Philippines since 2012 to 2022. So we are going to, if you're just going to read this in raw form, you can actually see pattern, right? So it's much better if you can tell story by creating a chart for this. So to do that in Excel, all you need to do is just to select the data set and then click the insert button here at the topmost part of Excel. And then you can either select any of these charts. So we have the bar graph here, we have the hierarchy chart, we have the line or area chart, and so on. But I recommend for quicker access or quicker accessibility, you can just click recommended chart, and then it recommends what data is, what chart is appropriate for this type of data. So since we're just going to see data over time or see a trend, we can actually use the line graph or a bar graph. So let's just put a line graph here. Oh, there. And then don't forget to label your chart. So put in the title, so population of what? So it's still questionable. So if you're just going to copy the whole title here and then paste it here. So there. So this is the population of Philippines since 2012 until the present. So if you are going to, if comparing to just seeing this one, the raw data, you can actually see pattern. Although you can analyze it one by one, which is the highest or the lowest. However, it would take you a lot of time if you are given a lot of data compared to if you're just going to graph it out like this. So you can actually see a trend. You can infer or you can assume that the population of the Philippines is actually increasing from 2012 until 2022. Okay, so let's go ahead and go to the second worksheet. This is now on the dirtiest air from highest to lowest. So the keyword here is highest to lowest. So therefore, we need to arrange this data set first from highest to lowest. To do that one, you need to select the data set here first. So always remember to select the values first, the AQI, and then click on this one, sort and filter. And then you can select largest to smallest. So there. So the dirtiest air from highest to lowest in pH is actually Davao. I'm not sure if this is true, but yeah, assuming that this is correct. So if you're going to select, so if you're going to present this data graphically, all you need to do is just select the data set and then click insert and then choose a recommended chart. So yeah, you can actually use bar graph since you will be comparing different categories or different cities. So we can just use this one. So there. Assuming that AQI is, the higher the AQI, the better the air, we can assume or we can see on the trend that Davao City has the cleanest air in the Philippines, and then Olongapo has the dirtiest air. I don't know if it's true. Yeah, if you wish to verify the information, just go to this website below, iqair.com, to verify. But based on this data, Davao City has the highest AQI. Okay, and then don't forget to paste the title or to label or put a title to your chart. Next is worksheet number 3. So this is the population of university colleges. So this is just simply comparing different colleges. So we can still use bar graph here. So this one. Then just copy the title. And then for the fourth worksheet, we are actually getting we are going to present the monthly expenses of a Filipino family from this source, from this given data. So the item here goes, 64.3 of the monthly expenses of Filipino family goes to food. For transportation, that's 14.3. And then for other things, miscellaneous, that's 21.4. And then if you're going to get the sum of these values, 64.3 plus 14.3 and then 21.4, this is actually 100%. So we are dealing with proportion here. And then for proportion, the better, the ideal chart for us to use is actually pie chart. Okay. So we can actually use pie chart here to present the monthly expenses of Filipino family. So majority, if we are going to watch or see this pie chart, we can say that majority of the expenses of the Filipino family goes to food. Okay. Next worksheet number 5. For this one, we are going to, this is a simple comparison of GNP of European countries. So we have categories and then we have values. We can just present this using bar graph. So this one, the GNP of European countries. So there, for the year 1995. Next is worksheet number 6. And for worksheet number 6, we're actually comparing two variables here. First is the enterprise size, which is micro, small, medium, and large. And then its contribution to establishments, employment, and then sales, and census value added for each. So we have two variables here. So the best practice, or what we can do for this one, since we have common items or common variables for each enterprise size, for micro, small, medium, and large, we have establishment, employment, and sales, and census value added. We can actually just rewrite this graph this way. So we have the, wait. Oops, sorry. We need to insert a cell above, so we can represent, or we can arrange this data set to this one. And then all we need to do is we just copy these values. There. So what we're going to do here is we select this data set and then click insert and then recommended chart. So we can actually use stack bar graph because we are comparing two variables here, the size of the enterprise as well as its contribution to establishments, employment, and sales. So there. So this is an example of a stacked bar graph. So this is 2020 MSME statistics. MSME means micro, small, medium enterprise. Next is this one, 7. This is a theoretical value for ramen sales. So we are going to determine, or we are going to present this data set in terms of sales from 2019 to 2022. So we have two categories here. Two variables here. We have the variable for the year. We also have the variable for the sales. So if you're going to select this data set and click insert, you can just click recommended chart and we can have a line graph or a bar graph here, or a clustered column bar graph. So it depends on you, but you can actually use both, but I think the line graph is more ideal because you can see trends on a specific time period from 2019 to 2022. Okay. So based on this chart, you can say that the sales of fish is actually lower than beef, pork, and chicken. And then the item that has the highest trend of sales is actually the pork ramen. And the trend for it is actually increasing, and then for fish, it's decreasing. So you can it actually guides you on decision making for your business. Next is electronic sales. So this is the same. This is the same with the previous worksheet, but we are dealing with percentages. So the type of electronics are smartphone, TV, and laptop. So we click insert and then recommended charts. It will be comparing two variables still, the year and the item, the percentage of sales. We can use bar graphs or clustered column bar graph, or we can actually use stack bar graph. So the stack bar graph is ideal for this one since we're dealing two categories, the year and the item being sold in terms of percentages. So we're not compared to this one, we're dealing with sales over time. That is not a portion of a proportion. For stack bar graph, we're actually dealing with portion of the whole percentage. So the percentage for smartphone, TV, and laptop. So there's a certain area here in stack bar graph that shows the portion of sales for smartphone, for TV, and for laptop. This chart is maybe it can be used to sales department, so it guides them on their insights or in their decision making for marketing. Next is, yeah, there's already a chart here, but yeah, given that there are no chart for this one, so we're actually comparing 4 rounds here, assuming that rounds are in time period or expressed in time period, and we have tomato, the sales of tomatoes as well as the sales for apple. Let us verify if these are percentages or no. So it doesn't equate to 100%. So meaning we are not dealing with a portion of a whole. Uh, this is not 100%. So we don't have a proportion here. So in this graph, we can just actually present this either a bar graph comparing two variables, the tomato and the apple, as well as its sales from 4 different rounds. We can present it in a clustered bar graph or a stacked bar graph like this, or we can present it in a line, multiple line graph. So we can present it like this, assuming these are trends in tomatoes and apple sales. Okay, so we can infer or assume here that the sales of tomato increased in round 4, whereas the sales of apple is consistent or somehow consistent over time for 4 different rounds. And then lastly is this example. We are going to compare the annual sales. I don't know what sales this is, assuming that this is the sales of a company compared to its percent sales. So maybe this is the contribution margin in terms of percentages. So we have variable for sales, profit, and then percent sales. These are the categories. We also have the variables for time period, and then we have the variables for the values of sales as well as the proportion. So the ideal chart for this one only, for the sales, is we can actually present this um, in a bar graph because we're comparing annual sales and profit. However, the percent sales can be presented in a different manner, but we need to present this as one in a graphical presentation or in a graphical form or in chart. So to do this, you just select the data set, click on recommended chart. So we can actually get the clustered column chart with line graph. So this is a clustered column bar graph or a clustered bar graph with line graph along it. So if you can see, it's actually comparing the sales and the profit from 2017 and 2022. And at the same time, it shows the trends on its contribution to profit or the percent sales. So from 2017, the contribution is between 5 to 10%. So yeah, it's 7% here, it's true. But it boosted on the 2019 sales with a highest contribution of 33%. And then the annual sales is just relative. I mean, it's just moderate. So it's actually questionable if the marketing department is going to see this report. They are going to look at what happened on 2019 and 2020 that boosted their sales up as well as its contribution. So yeah, again, data are generally used for decision making. Okay, so I guess that wraps up my discussion. By the way, don't forget we have an activity for this one, which will be shared to you later on. I hope you learned something from me today, and I hope you will have fun learning. Have a great day. Bye-bye.